Dos, tres, cuatro.
Hi everyone, welcome to applications of trig functions. We're going to look at a couple different type of word problems today. So I don't want to be that teacher, but there are a couple of really common word problems that do come up, and we do need to know what each of those are. So expect that probably in your class you're going to see something relating to a spring going up and down. You're going to see some sort of Ferris wheel, and you're going to see something to do with a tide for low tide and high tide. So there are lots of other examples. These are related to wheel type questions in the Ferris wheel example especially, but those are probably the three most common examples. So we'll look at one of each of those and as well as one other example. Okay, so example one, we have a weight that's attached to a spring and it's set in motion, and it's given a formula right here, and it says, well, what would this look like, and would we be able to do a sketch of it? So let's begin with the sketch. So we have this right here, and there's no vertical displacement. There's no d value back here making it move up or down, but we do have an amplitude of 5, and it starts at 0, 0, and we know what a basic sine function looks like, where you go up and then you go to your minimum point, and then you return back to the x-axis. So with this example here, we would go up, come down, and then go back up. And how long did that take? Well, we know that the period is going to be equal to 2 pi over our b value, and our b value here is 4 pi, meaning that our period will be 1/2. So it's going to complete one rotation in half a second. Okay, so this is saying it will take half a second to complete a rotation. The question is saying, how many cycles per second does the spring makes? Well, if it completes a rotation in half a second, it will be able to complete 2 full cycles in 1 second. It asks us to sketch the spring for one period, and so we've done that right here. And if you take a look right here, this is at 0.5 seconds, and they're saying, well, let's see if we can find something to do with the maximum and the minimum points. And you can see in part C, they're going to be asking for that detail here. So if 0.5 is at the end of one cycle, that means that a quarter of a second, 0.25, would be right back in the middle there, meaning that your maximum point here would be halfway between 0 and 0.25, so 0.125, and then your minimum point here would be halfway between 0.25 and 0.5, so that'd be 0.375. So the question is saying, at what time will the first maximum and minimum extremes occur for this cycle? So the maximum will occur at 0.125 seconds, and the minimum will occur at 0.375 seconds. Okay, next up we have a Ferris wheel question. So for the next few examples, you're going to need a graphing calculator. So if you don't have your graphing calculator on you right now, I'd run and get it, because you're going to need to answer some questions that requires that. Okay, so a Ferris wheel has a radius of 20 meters and it rotates once every 40 seconds. Passengers get on at a point S, which is 1 meter above the ground. Suppose you get on at point S and the wheel starts to rotate. What would that look like after 2 cycles? Okay, so we want to visualize what's going on here, and I'm just going to draw the actual Ferris wheel itself. And if we think about this, and then they're saying it's 1 meter above the ground, that means that that low point right there, that would be at 1 meter. And it's saying that the Ferris wheel has a radius of 20, meaning that the distance from this middle point down here is 20, meaning that our middle point would be 21 meters above the ground, 1 plus 20. And then if you have a radius that's 20, our maximum height here would be 41 meters, because that would give you a gap of 20 meters and a gap of 20 meters there. Okay, so it wants us to do a graph of this. So let's graph height versus time. And they're saying, can you do this for 2 cycles? Now, the question is saying that we get on at its low point. We get on at point S, which is 1 meter above the ground. In fact, it'd be strange if we didn't get on at the low point. And we're going to go all the way up and back down and return back there in 40 seconds. And then we're going to go and do the exact same thing here. And because our period is 40, then at 80 seconds we'll have completed 2 full cycles. So now look at the diagram on our left, and let's see if we can now try and fill in a couple other key points here. So the maximum height is 41 meters, and our vertical displacement line is at 21 meters. Now, that's an example of our graph right there. And when they ask for an equation for it, we actually have a bunch of different ways we could write that. It's making a sinusoidal shape, meaning that we could graph this as a sine function or as a cosine function. We have a choice. And most of the time, I would think that it's probably a little bit easier to graph something as a cosine function because you can identify the minimum and the maximum values quite easily. So I'll give 2 examples as what you could have come up with for your function, but we just know that there's multiple examples as what it could be. So here's one example. Let's say that we are graphing right here where we're looking at that point 0, 1. And if we did something like that, and we were to say what would be its cosine function, that looks like an upside down cosine function. It's been reflected. It has an amplitude of 20, which was exactly what the radius is, and a vertical displacement of 21, and its period is 40 seconds. So using all of that information, we could say something like height as a function of time would be equal to, if you'd said y equals, that would be okay, but it's probably a little bit better to say height as a function of time, and we'll say it'll be negative 20 cosine. Let's leave the period for last. We want to know it as a function of time plus our vertical displacement is what our middle line is, which is 21, and our period is going to be 2 pi over 40, because that's how long it takes for us to complete a period. If you said pi over 20, that would be just as good. That looks a little bit unclear, so let me just write that a little bit better. 2 pi. There we go. Okay, can you think of a second way that we could also write this function? And so let's do this on the right here. We could say height as a function of time is going to equal, and let's treat it as a positive cosine function. So positive cosine function would occur right at the maximum there, which is halfway between the 0 and the 40 second mark. So at 20 seconds, you reach your maximum height. So we could say something along the lines of height as a function of time could equal 20 cosine 2 pi over 40 t minus 20 plus 21. So if you graph each of these functions, you would find out that they are identical to each other. So now we need to find out a couple characteristics for part C and for part D. And in order to do that, we need to put this into our graphing calculator. So pick either one of these two. I'll pick the first one, and I want you to put it in your graphing calculator right now and see what you would come up with. Okay, so take a look at what we have in our graphing calculator right now. So a couple things to pay attention to. First thing is you want to type in -20, not subtract 20. You want to make sure we have the negative button going in. So -20 cosine of 2 pi over 40. And then what we've done is we've opened up a second bracket right here of x, and then we've closed it twice. So the amount of brackets you open has to be the same as the number of brackets you close. So we open up 2 brackets, therefore we have to close 2 brackets plus 21. Now, if you had that and you graphed it, depending on your calculator, you want to think about a couple things. So one thing is you want to press mode, and you want to make sure that you're in radian mode. After that, if you're to graph this and you were to look at your regular graph, you would say, well, this doesn't show me what my intention was. So think about what the question was asking. The question was asking us to graph 2 full cycles. So if we go to our window, we know that our time was from 0 to 80. So let's make our x-min 0 and our x-max 80. And then let's go down to our y-min and y-max, which is representing our height. And our y-min was at 0, and our y-max was at 41. So let's round up and let's make it 50. Okay, and you can feel really good about that because that looks very similar to the sketch that we had. So part C and part D are asking 2 questions. They're saying, well, what was happening at 45 seconds? What was the height at 45 seconds? So in other words, 45 seconds would represent your x value. So you could go second trace value, and you want to know what's happening at 45. Press enter, and you get something here that's going to say that we would have a height of 6.9 meters right there. Okay, so that's our answer to part C, 6.9 meters. Okay, and then the next part is saying find out what's happening when you're 35 meters above the ground. So when are you 35 meters above the ground? So let's go back to our y equals, and let's go down to y2. And at y2, let's put in the equation y equals 35. And then that tells us right when we're at 35 meters. And let's find the first time that we hit 35 meters. So we want to find this intersect point. And to do that, we'll go second, trace, intersect. So you can either press 5 or go down to 5 and press enter. And we can scroll over until we're very close to there. And we'll go enter, enter, enter. And it's going to tell us that it hits 35 meters at 14.9 seconds. Okay, so estimate your height when you're 45 seconds into your ride. That was 6.9 meters. And then estimate one of the times when your height is 35 meters above the ground. The one that we found was at 14.9 seconds, knowing that there are multiple correct answers for that one. Okay, example 3. The sunrise for a non-leap year is given with this formula. And given something like that, they're saying use the formula to determine to the nearest minute when the sun rose on February 14th, the 45th day of the year. D equals 45. So you could do this using the graphing calculator component to see what that looks like, or you could just sub in 45 for D right away and then just see what you come up with for that. It might be interesting to see what it looks like over the course of a year by graphing that on your graphing calculator, but I'll leave that up to you. Because we're new to the graphing calculator portion, and because it looks like there's going to be something where they ask for that in part B, it might be best to be able to put that equation into y1 and see what happens. So why don't we pause the video right now, and why don't you see if you can find out the answer to part A, and then take a look at what's happening for part B as well. Okay, here we have our formula that we've put in for y1. As you can see, you can double check, make sure you have everything right there. It goes all the way to plus 6.1 at the end. Okay. Again, the number of brackets you open is the number of brackets you have to close right there. And then when you graph it, think about what you want to make your window. So for me, I made my window from 0 to 365 to show 1 calendar year. And from the Y min and Y max, knowing that my vertical displacement was at 6.1, it's going up and down 1.77, it made sense to have a Y min, Y max from 0 to 10. And so if we graph that, we get something that looks pretty good. They're saying what's happening on February 14th, the 45th day of the year. And so based off of that, if we find a value and we type in 45, it's going to tell us that on the 45th day of the year, the sunrise was at 7.1030621, and they want us to convert that. If let's take a look at the question again, and the question is saying, well, when does that happen to the nearest minute? Okay, so to the nearest minute, a common error would be, you may say it's at 7:10 a.m. But what you want to make sure you realize is that it's 7.1 hours. So we actually have to convert these decimals and figure out what that would be in minutes. What's 0.10 of an hour, or what's 0.1030621 of an hour? And so if you take that and you go back to the regular part of your calculator and you type in 0.1030621, and you convert that decimal into minutes by timesing it by 60 minutes that are in an hour, you get 6 minutes and something. And so we could say that means that it would be at 7:06 a.m. Okay, so let's see what we have right here. We can say 7:06 a.m. Okay. Use the formula to determine the first date of the year when the sun rose before 6:30 a.m. and the last date of the year when the sun rose before 6:30 a.m. Okay, so if we go back to what we had with our graph, we could now say, well, we want to know what's happening at 6:30 a.m. 6.5 hours. So we can graph something like that. Okay. And we want to find the intersect here and the intersect here. So we can go second, trace, intersect, and we'll go over to the left. We press enter 3 times, and it says 66.75. Okay, so based off of that, we could say that on the 66th day of the year, it still hadn't reached that sunrise time that we're looking for, but on the 67th day, it definitely did. So you have to think about your rounding with something like that. So we would say on the 67th day. Now, depending on what your teacher is looking for right there, you could do something with the calendar year and say, okay, well, January has 31 days, February has 28 days, March is 31 days, and then you could pinpoint the actual date. For time's sake right now, we'll just say that it's going to be on the 67th day. And then let's find our second one by going to our intersect again, and we'll scroll all the way over here. And on the 275th day, it is rising still before 6:30 a.m., but on the 276th day, it would not be doing that. So it'd be all the way to the 275th day. So between the 67th day and the 275th day, it'd take a while to figure out what day of the year was the 275th day. We would satisfy these characteristics. So use the formula to determine when this happens. So we'll say the 67th day and the 275th day. And then finally, it says, for how many days does the sun rise before 5 a.m.? Okay, so let's go back to y equals, and let's clear the 6.5, and let's write 5 a.m. And it would be, again, where we have to find these two intersects. So let's find our intersect. Okay, so, and it's asking for how many days does this happen before 5 a.m. So before 5 a.m. So on the 118th day, it's still rising after 5 a.m. and it's not actually until the 119th day that it would be rising before 5 a.m. So between the 119th day, and then let's go second trace intersect, and let's find our next one. And on the 223rd day, it rises before 5 a.m. But on the 224th day, it would rise above that red line. So up until the 223rd day. So if they're asking us for a range for how many days does it rise before 5 a.m., it would be everything between the 119th day and the 223rd day inclusive. And so you could actually then say it'd be 223 minus 119. It's inclusive. It includes the 119th day and the 223rd day, so plus 1. Okay, so I think we could do that in our heads. That would be 104 plus 1, so for 105 days. Okay. Okay, final word problem here. So here is our tide question. Now for the depth of water, it doesn't give us exactly it doesn't give us numerical values there, but let's just assume that our depth of water is saying that for every grid mark, that's representing a 1. Okay, so it's saying, what's an equation of the graph? Now again, there's many equations that we could possibly come up with for what they're looking for with this graph. This 4.5 here is, if it's not clear, is intending to say that that's a maximum value, just like this 16.9 right here is intending to be a maximum value. And so if you just join those two, that would create a full period from 4.5 to 16.9. Okay, and if you look at 3, let's go 4, 5, 6, 7, 8, it looks like our maximum depth is at 8 meters and our minimum depth was at 2 meters, meaning that at 5 we're going to have our vertical displacement right there. So again, there's many ways you could write what the equation is going to be, but let's say something like this. We'll say depth is going to equal, and our amplitude, if our vertical displacement's at 5, our amplitude is going to be 3. And let's write this as a positive cosine function. So if we wanted to write it as a positive cosine function, we could say 3 cosine 2 pi over, well, from 4.5 to 16.9 is 12.4 hours, okay, and let's say time, we've gone 4.5 units to the right, and we have a vertical displacement of 5. So something like that would probably be our most common answer for that. Okay, so based off of this, they're asking us a couple more questions. They're saying, when do you have a depth, or sorry, what's the depth at 2:45 p.m.? And then estimate to the nearest minute one of the times when your water is 2.5 meters deep. Let's find the first time for that. So again, I would recommend pausing the video and seeing if you could find a solution for B and C by graphing this on your graphing calculator. And I'll give you one heads up for part B right here. We haven't dealt with a question like this where it's asking for something that's 2:45 p.m. So if it's p.m., that means that on a 24-hour clock, that would be 14 o'clock. So 14 3/4 of an hour. So the 45 minutes is 0.75 as a decimal. So when you're trying to figure this out, 2:45 p.m. really means 14.75, and that's going to be a little bit tricky. So put this in your graphing calculator now, and let's see what we could come up with for B and C. Okay, so we've put this into our graphing calculator. So we're saying 3 cosine, open up, it automatically opens up our bracket, 2 pi divided by 12.4 of x minus 4.5, double close the bracket because we opened it up twice, plus 5. Okay, our window, let's look at it over the course of one day. So x min 0, x max 24, and for our depth, we can do everything from 0 to 10. You could change that if you want to, but our y min 0, y max 10 makes sense. So if we graph that, we get something that looks pretty good. Now the question is saying, well, what's happening at 2:45 p.m.? So if we want to know that, let's go back to our value and let's find out what would happen at 14.75. So we enter that in and we get a depth of 6.4 meters. Okay, so 6.4 meters, that's our solution for right there. You think about what they're asking for, and they're saying estimate to the nearest tenth of a meter. Yep, so 6.4 sounds great. Okay, and then part C, estimate to the nearest minute one of the times when the water is 2.5 meters deep. Okay, so 2.5 meters deep. We can go back to y equals right here, and let's go down to 2.5. And we can graph that. Happens several times, happens 3 times over the course of one day. Let's find the first time. So this first intersect point right here, second trace, intersect. And we get something that would say 9.5441371. Okay, so 9 a.m. and then we have to convert these decimals. So again, let's go back to finding out what would be 0.5441371 times 60. So we could convert this to the nearest minute. And if we do that, then that would round up to the 33rd minute, so 9:33 a.m. So if they're saying estimate one of the times, we'll say it's 9:33 a.m. Okay, so lots of graphing calculator stuff for today. Here's your homework. We'll talk about the chapter review in class, but there's some good word problems right there, and hopefully all of that went over quite well. Thanks.